Well, welcome everyone. We'll give folks another 30 seconds or so to join us, and then we'll get started with our seminar. So. All right. We're at 1 minute after, so we'll, in the interest of time, make sure our presenter has enough time for this great presentation upcoming, and for our Q&A, we'll go ahead and get started. So good afternoon, everyone, and welcome to this webinar in our science seminar series in spring 2022. So happy spring all. And this is brought to you by the Southeast Climate Adaptation Science Center. So my name is Carrie Furness, and I'm the program manager here at the Southeast CASC. And I'm joined today by Dr. Ryan Boyles, who's our USGS Deputy Director for the SE CASC. So in these virtual seminar series, we're highlighting SE CASC funded projects that support resource management actions across the Southeast. So I'll start with letting you know what to expect from today's webinar. So our plan is to go over a few quick meeting logistics. We'll request some short feedback by a quick poll, and then we'll introduce our speaker for today, who will present for about 40-45 minutes or so, and then we'll have lots of time for Q&A and discussion at the end before we wrap up. So I will advance here. And so let me just quickly cover some of the features of Zoom, though we're all Zoom pros at this point, but do recognize people use different interfaces. So I'll just print out or point out a few things here. Controls at the bottom left allow you to mute and unmute your audio, ask you to keep both your audio and your video off so we can lessen distractions for our presenter. In the chat window, please feel free to go ahead and throw questions in as they come up during the presentation, and Ryan and I will be monitoring those and presenting them to our to Katie at the end of the presentation. And we also will be recording this presentation. We are recording this presentation, and you can review that at the, after the webinar, and we'll be sharing that via our Southeast CASC website and on our YouTube channel. So I encourage you to review it again. So now we're going to launch a short poll just to get a little bit of information about who's with us today. Maybe that helps our presenter as well to know who's with us, and also how we can continue to get information out about these webinars. So if we can launch that now, here we go. I see this. So yeah, so looks like we've got a fair number of federal agency folks with us today. State agency, NGOs, nice. So Katie, this might help you know how to, what questions to anticipate perhaps. So yeah, we appreciate this feedback. This helps us know, again, who we've reached and how to maybe continue to reach you. So thanks for reading the Southeast CASC newsletter. I hope you had a chance to see it this morning. Feel free always to provide feedback about that and potential input if you'd like, if there are other things you'd like to see there. So we'll go ahead and end that, and I'll say thank you again for doing that. And then we will, now I will stop sharing and we'll transition to our presenter, and while invite Ryan Boyles to introduce our speaker.
Thanks, Carrie. Thanks to everyone for joining us today. I'm very pleased to introduce our speaker, Katie Warnell, who's a policy associate in the Ecosystem Services program at the Nicholas Institute for Environmental Policy Solutions at Duke University. She works on a range of projects, broadly incorporating ecosystem services in decision-making and sort of planning context. This includes including state level natural and working lands planning for the climate and resilience benefits projects work she's been doing in North Carolina. She's done work in the Gulf of Mexico, looking at sort of how do you track coastal benefits for the projects as part of the work going down there with restoration, and things like mapping changes to coastal habitats for blue carbon, sea level rise, impacts in the East Coast. Katie has Master in Environmental Management degree and Geospatial Analysis from Duke University. And today she's going to be discussing some of the work that she's been doing as part of her funding through the Southeastern Climate Adaptation Science Center with Lydia Olander. The title of her talk today is Incorporating the Benefits of Natural and Working Lands in Conservation Planning. With that, I'll turn it over to you, Katie. Thanks for being here today.
Thanks, Ryan. Thanks, Carrie. Thanks for having me. It's always great to interact with the CASC. And as Ryan said, I'm here today on behalf of work with Lydia Olander, who directs the Ecosystem Services Program that I work in at the Nicholas Institute. We're part of the Southeast CASC Symposium, and so that's given us a great opportunity to be able to participate in a lot of this work. So I'm going to be talking mostly today about work to incorporate the benefits of natural and working lands and conservation planning through our work with North Carolina. So one of the Southeast CASC states, and obviously the one where we are located. So as some of you might be familiar, we have a lot of natural and working lands in North Carolina, which we're defining pretty broadly as any forest land, wetlands, agricultural lands as well, and then also our coastal areas. So more than 80% of our land area in North Carolina is natural and working lands. It's mostly privately owned. And as you can see on the bottom here, our natural and working lands really contribute a lot to our economy, and they really also provide some of the unique character for North Carolina, particularly when you think of the coastal region and the mountain regions where people come to recreate and to visit. So we know that our natural and working lands are creating a lot of benefits for the state, and it's really exciting to see the state moving forward to consider some of those benefits in their planning. So I'm going to touch on several different types of work today, several different projects. They really all stem from our work on North Carolina's Natural and Working Land Action Plan, which is where I'll start. But I just include this slide so you can kind of see how that work has spun off into several different projects that have kind of continued out pieces of the work and answer some of the questions that were raised during that initial work on the action plan. So I'll talk about everything that's on this slide today, at least for a minute or two. Obviously, you don't have too much time to get into a lot of detail. So over the past few years, there's been increasing interest in North Carolina in our natural working lands, particularly as a carbon sink. The chart here shows the greenhouse gas emissions inventory for the state for 2017. There was actually just recently an updated version released of that inventory, but it shows something very similar, which is that that purple column there, which is land use and forestry, is really the carbon sink that our natural and working lands provide. So it offsets about 25% of the gross emissions in the state for 2017. And because we now have some state goals for greenhouse gas mitigation through Executive Order 80, including reducing our total net greenhouse gas emissions to 40% below 2005 levels within the next couple of years, we really need to make sure that we're maintaining and increasing, if possible, that carbon sink to reach those goals. So a few years ago, there was an interest group, the Natural Working Lands Group, that was formed to develop an action plan for natural working lands in North Carolina with two primary goals. The first is related to greenhouse gas mitigation and increasing carbon sequestration. Then there's also quite a bit of interest in resilience. This is during the time period when we had several damaging hurricanes hit the state within a few years. And so resilience became a big point of discussion, as well as other co-benefits that these lands provide. So in the table on the right here, you can see the core goals that went into this natural working lands action planning. So ideally, we were trying to develop recommendations for how state agencies can manage the natural working lands, and then also how the state can incentivize private management of natural working lands to achieve those goals. So this was a relatively large group. There were about 90 people in total trying to develop these recommendations, and we kind of split into subgroups focused on different pieces of natural working lands in the state. And Lydia and I were involved in several of these. And one thing that we quickly started to hear was these questions that were coming up across multiple groups. Pretty basic questions really about the kind of what recommendations might actually look like on the ground, how much land area might be affected by certain recommendations to kind of allow them to compare the geographic scope of different types of recommendations. And then also benefits related questions. So wanting to understand what the current state of carbon was in these natural working lands, how management actions might affect that, and then also what kinds of resilience benefits management could provide. And then all of that kind of culminated in these questions about where we should be focusing actions to maximize benefits and support multiple benefits in one location. So we're hearing these questions across the groups, and what we ended up doing in our primary role in this process was a mapping project to answer these questions and provide the information the groups needed to develop their recommendations. So this is an overview of what we ended up mapping. So we had a few different types of natural working lands that were kind of addressed separately through this process. And for each of them, we had one or more kind of types of opportunities that were being discussed for recommendations that we wanted to map to answer those questions about the geographic scope, and then also about carbon and other types of benefits that, that action in these areas could provide. So I'm going to quickly go through a series of maps to show you kind of the sort of work and the sort of outputs that we ended up creating for the action plan. So the first set is what we call opportunities mapping, and this was trying to identify the potential geographic scope of different natural working land management actions in North Carolina. So this is the first one here is for forest protection. There's a lot of discussion about the need for increased forest protection, but they just had questions about, how much forest do we have? How much of that is already in protected areas? Those sorts of questions. So this map shows all the forests in the state, and then the gray areas are forests that are already protected. And then the opportunity for forest protection, if you were to protect all of the unprotected forests, is just over 15 million acres. So this is probably our largest opportunity for action just in terms of the total geographic scope. Obviously, there's a lot of discussion about what is realistic. We're certainly not going to protect all of the forests in North Carolina, but this is a starting point for discussion, and then later for kind of focusing on specific areas where we want to actually implement some of these recommendations. Similarly, we did an opportunities map for reforestation. So this is a kind of our final recommendation, which identifies a little over 500,000 acres for reforestation. We started out just looking at the biophysical conditions that can support forests, and then you have more than 5 million acres of potential. But a lot of that is in agricultural land, and obviously that land is in use and is productive and providing value for people. So we didn't want to end up recommending that a bunch of agricultural land should be converted to forests. And so we removed higher value agricultural lands. And then we also eliminated any patches of reforestation areas that were less than 10 acres, just because of feasibility of doing those kind of really small projects. So you end up here with just over 500,000 acres of opportunity for reforestation. This one's a little harder to see because it's smaller areas, but there's also some discussion about the potential for coordinated buyouts of developed land in the floodplain. So the pink on this map is mostly concentrated along river basins, along floodplains, along the major rivers, and then also along the coast. So these are areas of developed land that's in the floodplain and also in census tracts that's had historic flood insurance claims. So this is, again, just a first pass at looking at what areas might be good opportunities for buyouts. Buyouts in particular are very tricky to implement. They're voluntary, and so there's a lot more that has to happen for buyouts to actually occur. And then finally, we are interested in marsh migration. So with sea level rise, there's potential for a lot of movement along the coast in terms of habitats shifting there. And coastal marshes and salt marshes are very important habitats for recreation, for fisheries, and also for protecting our coastal areas from storms and waves from hurricanes. So we looked at the potential area that could provide opportunity for marsh migration inland, and looked at how much of that is already in protected areas. Some of the big national wildlife refuges along the coast have a lot of marsh migration opportunity and are already protected, but there's quite a bit of additional land in blue here. Again, just a little bit over 500,000 acres. that is not protected and might be suitable for marsh migration. This is another opportunity that's a little bit tricky because lots of those areas are being used for something else right now. Some of it is kind of open space, but some of it is agricultural. There are also some communities that are at risk from sea level rise and marsh migration. And I should note that this is showing marsh migration space through 6.5 feet of sea level rise. So it's pretty extreme. This is, not going to happen in the next couple of decades, but perhaps in the next 100 to 150 years, depending on climate projections. That wraps up the opportunities mapping. And then the next question people were asking was about carbon. So trying to understand where we currently are with our carbon stocks and what might happen if different scenarios for management are implemented. So we started by doing some carbon mapping of carbon stocks in our existing unprotected forests. So going back to the original recommendation that was being worked on. And the total here is more than 5.5 billion metric tons of carbon dioxide equivalent. This is equal to more than, I think, 35 years of our state's annual emissions. So it's quite a bit of carbon that's stored in these forests. We also looked at how much carbon these existing unprotected forests are sequestering annually. So versus stock, which is what's kind of sitting there in the forest, sequestration is what's being added every year. And the total is about 26 million metric tons of carbon dioxide equivalent every year. For context, our state's gross emissions in 2017 were about 150 million metric tons. So these forests are really offsetting a significant portion of the state's emissions. We also looked at resilience benefits. So there were a number of different benefits to communities, which were kind of collectively defined as resilience benefits, that protecting and enhancing the natural and working lands, particularly things like forests in the floodplain or wetlands, lots of these are related to water quality or water quantity, can help to provide. So this map is showing an overlay of, 4 different resilience benefits. So unprotected forests and woody wetlands that are contributing to protection of water supply, that are contributing to air quality in urban areas and urban cooling, that are contributing to reduction of downstream flood risk, reduced water quality risks, and then the pink areas contribute to multiple of those benefits. And then all of the gray is the rest of the unprotected forests and woody wetlands that didn't fall into one of those categories. So this is how we started to narrow down what areas the state might want to focus on in terms of recommending action for either preservation of natural and working lands or restoration, would be to focus on areas where you're getting one or more of these resilience benefits from that action. And this map actually comes right from the action plan. They ended up recommending, there are many, many recommendations in the plan kind of separated by different types of natural working lands. But at the beginning, there are a few transformative recommendations. And one of those is to conserve 1 million acres of currently unprotected forests or woody wetlands that would contribute to one or more of these resilience benefit. And so it's based on this map. And then if you may remember from the earlier slide with the goals for this process that equity was one of those. And I would say, the group as a whole had a lot of discussions about how to include equity. I've heard lots of discussions the last few years about how we can best do this. And I think we're certainly still figuring that out. So the way that we did that for this project, very simplistically, was to overlay some social vulnerability information. This is based on the CDC's Social Vulnerability Index, and it's basically identifying the census tracts within North Carolina where the demographic and social characteristics of the communities make them more vulnerable, less able to respond to things like natural disasters, flooding, hurricanes, fires, anything that kind of disrupts daily life and the economy. So one additional way to focus work would be to look for areas that both provide those resilience benefits, which again are the colored areas on this map, that also are in places of high social vulnerability, which is a lot of the kind of eastern half of the state. So many of the maps and information from those maps that I showed you ended up in the climate risk assessment and Resilience Plan. That's kind of the overarching document. And then the North Carolina Natural and Working Lands Action Plan is an appendix to that state document. So if you're interested in seeing more detail on how that all ended up in those recommendations, I'd direct you to that plan. There is still work ongoing now to try to implement some of the recommendations in that plan, which has been, it's a new phase of work. It's been a multi-year. I think we're going into our 4th year of work on this. So it's been a long process to keep people engaged. But there's lots of exciting developments in North Carolina, especially in the new state budget. There's some specific funding that's been earmarked for resilience of natural working lands. And so the DEQ and the other state leads on this, like DHP, are really hopeful that many of the recommendations in the plan can start to move into implementation soon. And then on the right here, we also put together a series of story maps to help to translate some of the information that's in that very long and kind of information dense plan into a product that's a little bit more accessible to the general public. There's recognition that we really are going to need support from the public to implement many of these recommendations and to kind of promote that sort of action. And so the story maps don't have, of course, all the information that's in the plan, but they do introduce the importance of natural working lands in North Carolina, and they introduce some of the different ways that we might be able to increase their value, both for climate mitigation and then also for community resilience and for other economic and other co-benefits that those lands provide. All right, so that kind of wraps up the introduction to the action plan. Throughout that whole process, as we were pulling maps together, pulling data together from different places, we identified many other areas that needed additional work. So there were some questions that we just couldn't answer for people because there wasn't the right data or information. And some of that we've been able to follow up on since the action plan was initially published near the end of 2020. So a lot of those questions related to precosins, which for anyone not from North Carolina and maybe not familiar, these are shrub bogs that are found in the eastern part of the state. There's also a few others scattered throughout the southeast, but North Carolina does have a high concentration of them. And they're really important for habitat, for hydrology, and also for carbon. They've got really deep peat soils that store a lot of carbon. In North Carolina, many of these precosins have been ditched or drained, usually about 100 years ago, so that they could be used for agriculture and silviculture. And these drained precosins are very vulnerable to fires, which release large amounts of carbon. As you can see on the right here, those tree roots kind of going down several feet, that's all where peat and carbon was lost due to a fire. Precosins were one of the specific natural working land types that were focused on during the creation of the Natural Working Lands Action Plan. And when we were trying to put maps together for those, we realized that the most recent statewide precosin maps were from 1999. And the data that were used for those maps was even older. So there was a lot of interest from state and federal agencies, as well as NGOs, in having updated maps. First, to help them identify precosin areas with restoration potential, and then second, to improve estimates of carbon storage in precosins. Due to a lack of data, we had treated them as forests in our carbon analysis for the action plan, which really is underestimating their soil carbon stocks. So since then, we've started to address some of those questions. We haven't made it all the way through yet, but one thing that we have been able to finish is updating the precosin maps of kind of where they are and what their current status is. We weren't able to recreate the 1999 methods entirely because they did extensive field work as part of that. And then also just many of the data sets that they used to identify precosin areas haven't been updated all that recently. So instead, we adapted our approach. We used those older maps to define where precosin areas are. And then we updated the land cover information. We used a new data set that identified plantation forests. And then we used newer hydrology data on ditches to map the current status of those areas. So overall, we found that more than 75% of precosins have natural forest or shrub cover. So they're not plantation forests and not cleared. So that is good news. However, slightly more than half of precosins have some ditching. So there's a lot of potential out there for restoration. There's already been some significant restoration on federal land. We know the National Wildlife Refuges have done several projects where they're rehabilitating ditches to restore the natural hydrology. And there's also been some private efforts, including the Duke Carbon Farm, which is working to restore an area of degraded Pocosin to generate carbon credits. So there's a lot of exciting work going on. And we've heard lots of interest from both state government, from NGOs, and from federal agencies as well in continuing to identify areas that are good candidates for restoration. One area for future work is to improve the ditch mapping. We're using a national data set for ditch mapping currently, but we know that that misses some smaller ditches and that it also might be outdated in some areas. It's not catching some of the more recent work that's been done to rehabilitate ditches. And so that's one of the main ways that we're identifying what areas need to be restored. And we are currently working on a proposal to get some funding to update that ditch mapping using new LiDAR data. And then the other half of the future work is on the carbon side. So as I mentioned earlier, we're currently really underestimating our carbon stocks in Pocosins because of that soil carbon. And the peat that contains all that soil carbon varies from maybe like a foot deep to potentially several meters deep, depending on where you are. And the information that we currently have about peat depth, which is highly spatially variable, is from some surveys that were done in the 1970s and 1980s by energy companies who are interested in peat mining. So that data is quite old. It doesn't cover the entire extent of Pocosin areas in North Carolina. And we have some ideas for new remote sensing data collection or field data collection to improve this, but we require additional resources and interested researchers. It's kind of outside of the scope of what we do at the Institute, but we often work with partners to get some of this done. There's also several ongoing research studies that are measuring carbon in Pocosins in those peat soils. And so we're also waiting for some new field data from that to be released as they're working on dissertations and papers and things like that, so that we can start to compile that information. So this is work that will likely continue for the next few years, especially if we get some funding for some of these improvements. All right, another area that came up during that North Carolina Action Plan process that we couldn't fully address through that, but we were able to leverage our initial work with North Carolina into a grant through the U.S. Climate Alliance to extend that both within North Carolina, but also northward, was about how sea level rise will affect coastal habitats and blue carbon. Obviously, we knew that there was interest within North Carolina in this topic. When we started talking to other states that are part of the U.S. Climate Alliance, North Carolina is currently the only southeastern state that's part of that group. We heard that there was a lot of interest within all the coastal states that we spoke with in thinking about what might be happening to their coastal habitats, and then therefore how they might manage their coastal areas to account for those changes. So our work was to map the blue carbon that's currently stored in these coastal ecosystems. So we looked at coastal marsh, but also at seagrass, and then also to project how the habitats and the carbon will change in the future due to sea level rise. And as you can see on the map here, we did this for 6 states on the East Coast, from North Carolina up through New York. So we developed a spatial model that projects how the extent and location of coastal marshes will change due to sea level rise. There are 2 basic responses that marshes can have to sea level rise. They are, in many cases, and this is what they've been doing historically, able to keep up with sea level rise through accretion. So as tides move over marshes, they trap sediment onto the marsh platform, and that allows the marsh to build up elevation and keep up with sea level rise. So if you look at like the long-term historical record, you'll see that changes in marsh elevation, generally speaking, match the rate of sea level rise where those marshes are. However, that ability depends on having enough sediment in the water for them to trap, and it also depends on the tidal range that brings that sediment onto the marsh. There's also the potential to move up or to migrate inward with sea level rise. So obviously, as sea level rises, it'll inundate new areas along the coast that were previously above high tide. And if those places are not developed and not somehow, unavailable to marshes, marshes in many cases can move inland. And this has also been seen in the historical record. There's been some papers published for the Chesapeake, that I think about 30% of their current marsh area was created through marsh migration in the last 200 years. So both of these processes are things that are happening on a large scale. And then if a marsh is in a place where it's not able to keep up by vertical accretion and it doesn't have anywhere to move, then it's likely that that marsh will drown as it is inundated by sea level rise eventually. And when we pulled all the data together, we kind of wanted to see, using the best available data over this large extent that we were working on, what that would say about the marshes in these states and their ability to keep up or migrate inward with sea level rise. And what we found was that, let's go through one line at a time here. There's a lot of potential for inland migration. That's the pink line. So you can see that starts from 0 with our baseline year, and then it increases quite a bit through mid-century. The sea level rise projection that we use predicts about 1.5 feet of sea level rise by 2050 and about 4 feet by the end of the century. So there's quite a bit of potential for inland marsh migration through mid-century, and then it declines a little bit. We have a lot of really low-lying land, and a lot of this is in North Carolina, that becomes available for marsh migration initially, but as sea level rise continues, more and more of that new migrated marsh area actually becomes inundated itself and is no longer kind of in the right spot related to the tidal frame to continue to be marsh. So the total area of inland marsh migration actually goes down a little bit by the end of the century. And then the purple line is the original coastal marsh. So we found that for the study area we were looking at in the sea level rise scenario that we were using, our marshes are very vulnerable to sea level rise. A lot of this is because they're generally in microtidal environments, so they don't experience much of a tidal range, and that really limits their ability to keep up with sea level rise. And they also are kind of already at relatively low elevations relative to the tidal frame, so they become vulnerable to sea level rise very quickly in our model. And then the gray line is just the sum of the two. So you can see that initially with a little bit of sea level rise, you end up with increased area of coastal marsh, but after that it declines. And at the end of our analysis period, we end up with about 30% of the original marsh area. And then the other big change to think about is that during this period of marsh migration, it's not moving inland into these like just totally barren areas. It's replacing other habitats that are in that transition zone. Along the mid-Atlantic coast we're looking at, this is the transition zone is primarily forested wetlands, other types of freshwater wetlands, and upland forests. And so this becomes a big part of the carbon story that we will get into next. So both the coastal marshes, the seagrasses, and the upland habitats and freshwater wetlands they all have their own carbon cycles going on. That kind of varies based on the habitat you're in, but they're all currently storing and sequestering carbon in their soils and in their vegetation, especially if you're looking at an area that has trees. And some areas, especially freshwater habitats, are also emitting some carbon as methane. So we estimated how much carbon our entire study area, which includes both the transition zone and the existing coastal marshes, how much carbon would be sequestered over the next 100 years without any habitat changes, and then also how much carbon would be sequestered or emitted with the projected habitat changes due to sea level rise. And this is just a summary of the habitat changes that show up on our model and how they translate into carbon changes. So if you lose a coastal habitat like marsh or sea level rise, there's likely to be some level of increased carbon emissions because of decomposition and sediment loss. When you convert terrestrial habitats to coastal marsh through marsh migration, you get increased carbon emissions through biomass mortality. We're already seeing this in North Carolina with our ghost forests along the coast. But you also get some increased carbon sequestration because you have new marsh being established, and often coastal marsh can sequester carbon at a higher rate per unit area than even a terrestrial habitat like a forest. And then finally, as we have conversion of freshwater wetlands to coastal marsh, which is basically increased salinity coming in, that is associated with lower methane emissions. Having more saline water inhibits methane emissions, and so you get decreased carbon emissions. So we've basically done this accounting where we've kind of tallied up, all of these carbon changes that are associated with the projected habitat changes to see what sea level rise actually does to the overall coastal zone and its carbon balance. And of course, there are a lot of uncertainties here, which I'll get into in just a minute. So keep that in mind while we look at the results. So we found that overall sea level rise is likely to cause the coastal zone to switch from a carbon sink, which it currently is, to a carbon source. And then the major reason for this is due to carbon that's being released from biomass in the migration space when forests and forested wetlands convert to marsh. So there is that expansion of marsh initially that I mentioned a few minutes ago. So there's potential for additional carbon accumulation that way. But that in large part just goes overwhelmed by the really shorter term carbon emissions caused by tree mortality. And this is for this particular sea level rise scenario, which is, it's called intermediate, but it tends to be on the higher side compared to what like the individual states are using. If you use a lower sea level rise scenario, of course, you get less habitat change. And so you get a little bit less of that carbon emission happening. But we did find that even with a lower sea level rise scenario, we still saw this switch overall. There just wasn't as much carbon being emitted under the sea level rise projection. So we reran the model multiple times to identify which of the assumptions that we are making, which of the uncertainties in our input data are having the largest effect on the results. One of the main outputs from this research is identifying these key targets for future research to improve these estimates. So one set of assumptions that made a big difference was about what parts of the coastal zone will be available for marsh migration. We have, one model that excludes agricultural land and land that's projected to be developed from converting the marsh, because there are things that people can do to prevent inland migration of marshes and saltwater intrusion. And in some places that's already starting to happen, building berms and pumping out water and things like that, although it is expensive. So when we allow marsh migration into those areas, it increased the future area of coastal marsh, but it also increased carbon emissions because we've got additional land conversion and additional emissions from biomass. The only version of the model that we ran in which the study area actually remained a net carbon sink under sea level rise was when we prevented marsh migration into forested areas entirely to avoid those biomass losses, but that's not something that's feasible to do on a large scale. Another set of important assumptions is about how much carbon is emitted when habitat changes occur. So in particular, how much of that biomass carbon is emitted when forests and forested wetlands convert to marsh. That's an area that there's been quite a bit of research starting to happen over the last year or two. We've seen some great studies from North Carolina where they use remote sensing to estimate biomass kind of along a continuum from a forested area to a ghost forest to a marsh. And they did see almost complete loss of biomass carbon over that transition, but still an area of active research. And then the other highly uncertain part of this is how much soil carbon is emitted when coastal marshes are lost due to sea level rise. This is a big unknown, I would say right now. There's been some lab studies that quantify this, but not looking at real conditions, what's actually happening to that sediment in an area of drowned marsh, and then how much of the carbon stored there is actually emitted to the atmosphere. And then finally, another big carbon flux in our model is methane emissions from freshwater habitats. Those are highly spatially variable, and the data set that we had to use, at the scale we are looking at, doesn't have all that much spatial variability in it. It's based on kind of these general habitat classes. And it did have kind of a range. And so when we used different ends of that range, we saw a big difference in the total carbon balance. And that affects the results even without sea level rise. So improving our ability to estimate those more precisely would improve those estimates as well. All right. So moving on to another piece that came out of the Natural Working Lands Action Plan. I mentioned earlier that we made some story maps to kind of introduce people to the concepts of the importance of natural working lands and kind of the key points from the action plan. We also had a lot of requests for pooling some of the data, like some of the maps that I showed earlier, for pooling results for certain areas of the state. So like for one county that they work in, for example, or for a certain river basin. So what we ended up making and releasing this winter was a set of what we call natural working lands dashboards for North Carolina. And these, there's 3 of them. So this slide showing the overview one, there's also one for carbon, and then there's one focused on conservation land. And each of them has kind of a summary of the current status and also trends where we have it in natural working lands. So this one has kind of on the left side, you can see it's showing how much of the total natural working lands are conserved, and then how they break down in terms of different habitat types. On the right side, we have more information about benefits. So the bottom has all of the resilience benefits that we talked about before, plus a few others. And then the top circle graph there is carbon stock. There's also a tab of sequestration. And we made these interactive so that we, kind of could stop going in and pulling out data for people, and they'd be able to do it themselves. So at the top, you can select either a county or a river basin that you're interested in, and the dashboards will update to show you the results for just that county. It also has some tabs on the bottom that show the benefits for the county or the river basin that you've selected compared to all of the other counties or river basins in the state. So this can help you to identify kind of which benefits are more important in different parts of the state. And we've heard that this sort of information can be useful for both communicating with different audiences, and also for developing things like proposals. So we've relatively recently released them. We hope that they're interesting and useful, and we welcome comments or questions about them if you do go check them out. We're hoping that this is a project that we can get a little bit of ongoing funding for, at least enough to hire like a student every year to work on, because we will have updates to the data, and we'd like to keep them obviously as up to date as we can, so that they can continue to be useful. And then the last piece of work that I'll touch on is just started this winter, and will be ongoing through the end of the year. And that's kind of building on these dashboards to turn them into a more specific tool for conservation organizations to consider co-benefits of conservation. So to expand the scope of the benefits that they're thinking about, to be able to incorporate additional benefits that maybe aren't kind of their main area of focus, but might allow them to expand the stakeholders that are interested in their work, or the sources of funding and things like that. And so we see 2 distinct parts of this tool. One is a prioritization tool that allows the user to select the co-benefits that they are interested in, and then it kind of highlights the parts of the state that would best fit those interests. So if you're, for example, a land trust, looking for new areas to work within your kind of scope of work within the state, you could find the places that would be most likely to support a wide range of co-benefits. And then the second piece of the tool is a benefits calculator for selected areas. If you, for example, clicked on a catchment, you would get a summary of co-benefits for that catchment, and also compare that catchment to all the other catchments in the state. So kind of similar to the dashboards, you would be able to compare the benefits provided by that small area to the rest of the benefits in the state, or the rest of the areas in the state, to see which benefits kind of pop out as being the most important or least important for that area. As I said, we're kind of just starting this tool. So we've done some outreach to land trusts and conservation organizations in the state. And we want to focus this work on co-benefits that they are interested in and think would be useful to have information about, but that they're not currently quantifying on their own. They don't currently have the tools to quantify. We don't want to create a tool that overlaps with what they're already doing, or that, that it's just one more tool and kind of among this long list of tools that maybe don't get much use. So we're trying to fill a gap rather than kind of recreate anything they're already doing. So based on that outreach, we've identified 4 co-benefits that more than half of the conservation organizations we surveyed are interested in, but told us they're not currently able to quantify or map. And those are climate resilience, carbon storage and sequestration, downstream flood risk reduction, and wild pollination. And then they also, many of them also told us that they are interested in how to incorporate equity. And so that's also something we'll be building into the tool. It's kind of a cross-cutting benefit rather than a specific co-benefit itself. And we're trying to design this tool using the framework of spatial action mapping. The idea is that we're focusing on the estimated impacts of conservation actions rather than just having snapshots of where there are conservation assets or where there might be threats to those assets. We actually want to know, what is the impact of conserving this piece of land rather than not conserving it. And so the approach that we'll most likely use for conservation, for land conservation, is to include probability of future development. So what would happen to that land and its benefits if it is not conserved? So for example, if there are two areas that have the same value for wild pollination, but one is only 10% likely to be developed in the next 30 years, and the other is 70% likely to be developed, the property that's more likely developed would be prioritized. And you can see how that would become more complex if you've got multiple benefits and maybe different weights among those benefits, as well as different probability of development among properties. And so that's what the tool will kind of integrate all of that information to highlight the areas that would provide the most benefits if you were to conserve them. So yeah, we're just in the kind of beginning process of this. We're working out kind of the workflow and the platform for this tool. And then we'll be building it this summer, and we'll be going through a process once we have an initial version of the tool to get feedback. And so if anyone is interested in this tool and might want to participate in that process, please feel free to shoot me an email. And that's my last slide about our work. So I'll stop there and just again, thank the Southeast CASC for their support of this work. It really wouldn't be possible without that source of funding, especially, all of that North Carolina action plan work did not have a specific funding source. It was a huge volunteer effort from many people across the state, probably including some on this call. So we were lucky to have that source of funding to make sure that we had time to spend on that. And yeah, feel free to reach out if you have questions that we don't get to today or ideas for future work. We are always looking for collaborators and partners on that. So I'll stop there. Thank you.
Great. Thanks so much, Katie. It was a great talk. We do have some time for questions here. If you want to ask any question, you can either put it in the chat box and we'll read it out to you, or you can raise your hand in the participant box and we will call on you to unmute yourself to ask your question. So we have a couple questions already starting to come in the chat. Thanks for providing those. Bill Copeland is asking about the kinds of extraction that's going on, and he gives a couple of examples there. Are we degrading some locations where we're sort of reducing some of that resilience or carbon storage potential? And is there a way to sort of reduce some of that? Connecting back to these concepts of sort of co-benefit work that you've been doing, as well as some of the sort of environmental justice questions that you'd raised.
Yeah, that's a great question, Bill. I think, like you said, it can be a thorny question. I think it gets to a level of detail beyond what we were able to look at for the action plan, but it was definitely something that came up quite a bit, especially on the forestry side, was that there are all these different ways to manage forests for different extractive purposes, some of which are considered, sustainable and, kind of good long-term options for keeping land in forests, but others that might be damaging the land itself. So I think this is an area that was flagged for future research and for specifically for North Carolina, the development of a more complex modeling tool that would look at those kind of specific management actions within forestry and be able to kind of estimate both the economic effects, but also the direct economic effects, but also the indirect effects through the impacts that those management actions have on the kind of long-term health of that land. So I don't think we can totally answer your question at that point, except to say that, yes, I think there are some sorts of management that do, impact the long-term potential of the land and its benefit for resilience and for carbon.
Great. Another question asking about the costs of acquisition and restoration, whether those would be included as part of your mapping tools in the future.
That's a great question. I think it would be helpful to have that sort of information in the tool. And I have seen that one example I had up in one of the last slides is kind of a screenshot of a tool from Minnesota that it did include costs of conservation And it was a relatively simple way they were able to do that. I think the question would just be whether we have good enough data that we felt like that was a useful addition to the tool rather than something that ended up being overly simplified. So I think that's something we'll have to talk more with the conservation organizations who have been interested in this tool and giving us input about, to see if we could come up with something that was reasonably detailed enough and realistic enough that it would actually be a useful thing to add to the tool.
Thanks. Other questions, feel free to use the chat or under the reactions. If you raise your hand, we'll call on you.
So Katie, I'll jump in with the question while others formulate their thoughts. So in thinking about Pocosin restoration, and I know you mentioned some emphasis on trying to get the ditching and see what, resolve some of those mapping, some of that mapping resolution. Is there thinking in incorporating in those somehow some of the timeline for what that's required? Because certainly losing peat is a lot faster process than rebuilding peat. And so how is there some estimate of sort of how long it will take a thing like a Pocosin to sequester carbon versus lose it, I guess?
Yeah, there are actually a few different reasons that Pocosin hydrologic restoration is helpful from a carbon perspective. So one is making sure that peat is wet so that you're less vulnerable to fires, which are obviously the fastest way to lose that peat. But dry peat also is oxidizing more quickly than wet peat. And so even without a fire, you're losing some of the carbon from that peat on an annual basis, which you can also stop immediately by re-wetting it. And then there's also the potential for increased sequestration going forward once the Pocosin is kind of more functional. And that takes longer, right, for the actual process, ecological processes to kind of reset themselves there. So I think there's a few different timelines going on. I would say the National Wildlife Refuges probably have the best data on that because they have done some restoration projects themselves on their lands and have been able to measure some of the impacts. I know the fire part of things in particular, it's pretty hard to quantify that benefit because it's, all probabilistic based on, whether you actually have a fire in a certain time frame or not. And then I'll also add that one of the main reasons that we need more specific and higher resolution and up-to-date ditch maps is to better understand how restoration will affect neighboring landowners. Even if the Pocosin itself that you're trying to restore is on public land or on conservation land, oftentimes the hydrologic restoration could end up affecting neighboring landowners who are, private landowners who were not intending to participate in that process. So what we've heard from some of the state and federal agencies who are trying to do this is that they've kind of addressed a lot of the low-hanging fruit in terms of restoration projects that they're confident, aren't going to affect neighboring landowners. And in order to kind of do that next step, they need to know who those landowners are who are more likely to be affected so that they can do the necessary outreach and make sure that, everyone is on the same page before they're actually able to start that process.
Great, thanks.
And I have a question, Katie. Are you aware of other initiatives in other states to try and do this kind of high level sort of opportunity and carbon mapping in the region?
Let's see, I've recently been looking into other states' natural working lands kind of action plans to see what's been happening and if anyone else is doing similar things. There are some states, I don't think any of them are in the Southeast, that have done some similar action plans, but whether or not they actually did some of the similar mapping type of work that we did, I don't know. I haven't seen that. I know that the U.S. Climate Alliance, which supported a lot of states in developing these types of plans, including North Carolina. They've done some of the carbon data assessment at the national scale because they have been very helpful to North Carolina and other states in kind of providing that as a starting point that we kind of built on and made more specific to North Carolina to understand the potential for management actions that can help with the carbon mitigation.
Any other questions folks want to pose? Feel free to raise your hand or you can type fast, put it in the chat. I have time for one more. All right, Katie, I'm going to jump in with one. So if you were a student or advising a student who's just getting started on a graduate program and looking to make a difference in this space of ecosystem services and valuing sort of some of these changes. What's the hottest topic, or what's the point of all those uncertainties and sort of research needs that you might point them to? Where would you think they could make the biggest difference in shaping a research program?
Sure. I think there's lots of room in this space. So if you've got the interest, you can probably find a niche for yourself. But I would say two areas that I've seen a lot of work on the last couple of years, and seems like there's a lot of funding for and interest in from, everyone from local governments to states to the federal government, is resilience. And that can be broad, right? There's a lot of work happening for coastal resilience, understanding the impact of different restoration approaches like living shorelines or marsh restoration on coastal communities, but also more on the social side, working on programs like flood insurance or disaster relief, and how we can make those programs contribute to resilience of communities rather than contributing to rebuilding homes and communities in places where they're at risk. And I've seen lots of students recently go into these sorts of roles with places like FEMA. And then the second area I would say has had just a lot of interest, a lot of work, is natural climate solutions more broadly. So that could include some of what I talked about today. So like natural working lands and carbon sequestration. And it could be in lots of different types of ecosystems, and thinking about things like carbon credits and financing options. So there's kind of a spectrum there as well, all the way from like the kind of hard science that informs those sorts of decisions to the kind of economic sides of things.
That's great, thanks. Well, we're getting close to the hour, and it does look as if several folks are asking for copies of your slides. So I guess you could consider, if you are willing to share those, we can PDF those and send those around to people who registered. And I'll mention too that we are going to, again, we're recording this, we will make that recording available as well. So I would like to close with just wrap up with letting you know about some other upcoming presentations. But before then, I would love to say thank you again, Katie, for that great presentation, and take this opportunity, if you wish, to oops, I'm trying to get this, share this, to clap for Katie. And I will get this, sorry, link the thing. Hopefully you're seeing the right thing there. But again, thank you again, Katie. And I would invite anyone on this on the call to hopefully join us for some other upcoming seminars, a couple of which are coming up, which are hosted by, planned and implemented and hosted by our Global Change Fellows, who are graduate students who are with us for a year. The next one upcoming is actually next week, on Tuesday of next week, on talking about why framing matters, and how we can communicate climate communication in more inclusive ways. And then there's going to actually be a series that our fellows are coordinating, and which is going to involve a film screening of a really amazingly beautiful film about Appalachian streams, and then followed by a panel discussion talking about climate futures. And then our next science seminar will be at the beginning of May, on some work that's being done at Gulf Islands National Seashore. So hope you'll plan to join any of those, and would like to say again, thank you to our presenter. Katie, thanks. It was a great presentation, and I hope you all have a great rest of your day. Take care.